From the Unit 5 practice final, let's do problem number 4. And I'll read the problem. It says, Elijah's shoulder is doing a lot better now. He is at the top of a tall building and throws a baseball as hard as he can horizontally. The building is 25 meters tall and the ball hits the ground 78 meters from the base of the building. A, find the initial velocity of the ball. B, find the final velocity of the ball the instant before the ball hits the ground, both magnitude and direction. Okay. So let's set this up with given, find, and solve, which I always do. So we've got a tall building, and we're throwing a ball horizontally off the top of it, and it's going to thunk. It's going to hit the ground with some final velocity like that. The building is 25 meters tall, and we hit the base 78 meters from the base of the building. The ball hits the ground. And so what are we trying to find? We want to find the initial velocity of the ball. And then part B, we want to find the final velocity of the ball. I'll just call this the final velocity. Okay. And let's solve this. And if I go off screen, let me know. Let's solve. Well, let's figure out what the initial velocity is. Notice that it says in the problem that velocity, that the ball is thrown horizontally. Now, what does that mean? Okay, that means that this really is the initial velocity is all in the x direction. The initial velocity in the y direction is 0, and you can write that in what's given. V naught y equals 0. Let's see. Okay. Now there's only so what we need is really the initial velocity is velocity in the x, and we really only have one kinematic equation in the x direction equals v naught x times t. So I really want to try to find v naught x. So v naught x equals delta x over t. Now I know delta x. Delta x is the horizontal displacement of the ball. It goes from here to here in the x direction, but I don't know time. And notice how the technique here. I start with a basic equation that has what I'm trying to find in it. I solve for it, and then I let this tell me what to do. I look at what's given. I know delta x is 78, but I don't know time. So now I have to think of a strategy to figure out what time it took. And then I have to look in the y direction. And in the y direction, the ball starts from rest but falls 25 meters. And so I can use that to solve for time. And I know what delta y is. It's negative 25 meters equals v naught y times t plus 1/2 a t squared, because I know what the acceleration is, right? Well, this is 0, so this whole term goes away. And now I'm going to solve for time. And we've done this many times. Pardon the pun. So just take this expression and solve for time. So I'm going to multiply delta y. I'm going to multiply by 2 to get rid of the 1/2, and I'm going to divide by the acceleration to get rid of the a. Now, this is really solved for t squared, and then I take the square root of all of that. And if doing all that in one algebra step is beyond your reach, then just do it one step at a time. Just very carefully solve for time. And then this is going to be equal to 2 times 25 meters. And the acceleration is negative 9.8 meters per second squared. And then you might plug this into your calculator and it's going to give you a bad result. It's going to say, no, that's not right. And then you go back and you look and you say, oh, okay, I can't take the square root of a negative number. So this negative has to cancel out. And then you go, oh, wait, I dropped 25 meters. So since down is negative, this delta y is negative 25 meters. So, you'll probably need that on the final to know to do that. So the negative goes away. I take out my calculator. So 2 times 25, well, obviously that's 50, divided by 9.8. I get 5.102. And then I take the square root of that, and I get 2.26 seconds. Okay. Now this is what I need to figure out what the initial velocity in the x direction is. It's delta x, which is 78 meters, and I'm going to divide that by 2.26 seconds. So the initial velocity is, let's see, 78 divided by 2.26, 34.5. And that's part A. Any questions on that? Okay. Zoom out a little bit so I can fit it. Now let's take a look at part B. Here's our final velocity, and it's going to have a velocity in the x and a velocity in final velocity in the y. Now, the thing about projectile motion, if you look at the baseball as it is right there, the only force acting on it is the force of gravity, which means there's no force horizontally. We're neglecting air resistance, right? No air resistance, so there's nothing to slow the ball down as it's flying through the air in the horizontal direction. And so the velocity in the x direction is just 34.5 meters per second. So we'll do part B over here. Well, but I want to get this vector right here, so I need to know what its y component is. And Vy equals V naught y plus a times t. Well, that's 0. So the final velocity of the y is just negative 9.8 meters per second squared times the time that it fell. Well, we know what time it fell, 2.26 seconds. Okay. And so the final velocity in the y is 9.8 times 2.26, 22.1. I'll say 1.5 meters per second. Oh, it's negative, right? It's negative because obviously the ball is falling down, and the negative means it's in a negative direction. Well, now that I've got the x component and the y component, I can figure out what the final velocity is, the magnitude, by taking the x component and the y component, which we just calculated. Now the negative isn't really necessary because it's getting squared. So 34.5 squared plus 22.16 squared equals 1,681, but then I have to take the square root of that, and I get 41. So that's the magnitude of the final velocity. Did you all get that? Okay. Now the angle is equal to the inverse tangent, and I want this angle right here. That angle is going to be the opposite over the adjacent, and the opposite is negative 22.15. And the adjacent is the is 34.5. So so let's see, 22.15 negative. And I get negative 0.642, and then I'm going to take the inverse tangent of that ratio. And I get negative 32.7. Then I ask myself, do I need to add 180 degrees to that? No, because the x component is positive. If the x component is positive, you don't need to add 180 degrees. And this is negative, it's below the horizontal. That just means you rotate clockwise from the positive x direction. So let's just write the whole thing out here. And there's my answer. Okay. Okay. That makes sense, everybody? Okay. That is all.